theorem of total probability. In this module, you will learn about the theorem of total probability. To establish the result for theorem of total probability, we start with the concept of the partition of a set. A partition of a set is a collection of non-empty, non-overlapping subsets of a set, that is, sample space, such that their union is a sample space itself. You can observe that non-empty sets A1, A2, A3, A4, A5 and A6 are the subsets of the sample space S such that the union of A1, A2, A3, A4, A5 and A6 is a sample space S. Also, all the subsets of the sample space are non-overlapping sets, which implies that the intersection of any two subsets is a null set. Thus, A1, A2, A3, A4, A5 and A6 represent the elements of this partition and are called parts of the partition. If B is any event associated with sample space S, then B can be expressed as the union of sets B intersection A1, B intersection A2, B intersection A3, B intersection A4 and B intersection A5. Now, the events B intersection A1, B intersection A2, B intersection A3, B intersection A4 and B intersection A5 are mutually exclusive events as they have no outcomes in common. Thus, according to the addition law of probability for mutually exclusive events, you get probability of event B is equal to probability of event B and A1 plus probability of B and A2 plus probability of B and A3 plus probability of B and A4 plus probability of B and A5. Since there is no region common to the sets B and A6, you can say that B intersection A6 is a null set. Thus, the probability of B intersection A6, that is, number of elements belonging to set B intersection A6 upon number of elements belonging to set S, is 0. Now, if you add the probability of B intersection A6 on the right-hand side of the expression for probability of B remains the same. We can represent right-hand side of the expression in terms of conditional probability. Thus, the probability of B is equal to summation of probability of B when AI has already occurred into probability of AI where I varies from 1 to 6. This expression represents the theorem of total probability for 6 parts of the partition. If the number of parts of the partition is equal to n, then the expression for theorem of total probability becomes probability of B is equal to summation of probability of B when AI has already occurred into probability of AI where I varies from 1 to n. In this module you have learnt that theorem of total probability states that if the set consisting of events A1, A2, A3 and so on up to An is a partition of the sample space S, and also events A1, A2, A3 and so on up to An have non-zero probabilities, then for any event B associated with S, probability of B is equal to summation of probability of B when AI has already occurred into probability of AI where I varies from 1 to n.